Okay, everyone, this video we're going to be reviewing significant digits and also going through the last significant digit and measurement quiz. So what I have here, I'm going to have some kind of object I want to measure. I'm going to be using a ruler, and this is like, say, a meter stick, and the meter stick's measuring in millimeters. So looking at this, I can say, okay, my reading here for the length of this object is going to be not quite halfway. It's a little bit less. Let's estimate it's around 400 millimeters long. So I have to record all the digits I know plus an extra. So I don't know any digits here, so I'm just already estimating this one. So the best I can do here is write down one quantity for the measurements, will be one significant digit. The zeros here, they just show you the size. They're not actually part of the measurement. So I don't include these as part of the measurement, or thinking about including them as part of the measurement. So here I've got a better meter stick. It has more markings or gradations on it. You can see here, oh, I've got 400 for sure, and I can kind of estimate, maybe it's around 420. So around right there, maybe around 420. So I was able to record all the digits I know, an estimated one. So I got two significant digits here. Remember, the zero here doesn't do anything, just shows you size. And finally, we've got this device. This meter stick, it has even more markings. So I've magnified this a little bit. You see here, oh, I've got 400 for sure, 410 for sure. So I can record all the digits I know. And then how about here, 410, maybe 413 or 14 millimeters. So you can see here, the better the quality instrument, the more digits that you can record, the more significant digits you have. So here I've got 3 significant digits. Here only 2, here only 1. So these zeros at the end up here are just placeholders. Now, hopefully it'll help you understand placeholders. All right, how about the same thing with electronic balances? So I put a little block on here, and this electronic balance can read to 0.1. Well, it's not too bad, so I write down 0.1 grams. How about here? Oh, this one can read to 2 decimal places. So that's a really good measurement. It's exactly 0.10 grams. So I can record all the digits. So here, at the beginning I had 1 significant digit, now I actually have 2. The 0 at the end actually tells people that, hey, I was able to read an extra decimal place, so it's a much better measurement than before. So it's called a trailing 0. And the last one, hey, I've got a 3 decimal place balance. Whoa, that's amazing. That must cost a lot of money. So you have 1, 2, 3 digits. These extra zeros at the end, they're actually part of the measurement. They're not placeholders. They actually tell you that the value here is 0 and 0. So you can read to 3 decimal places. So if I had this and I had this measurement, obviously the last one is much better and has 3 significant digits there. So I just want to remind you of that. So let's record some values here. So what I have are these measurements. So I'm using the first one. So I'm going to be looking at 6, 7. There are 10 marks in between, so that means each one is 0.1. So 6.1, 2, 3. So this would be 6.3. Looks like I'm about halfway. Oh, 6.35, and I'll put in the unit milliliter. All right, how about this one? This is an unusual one. This one, actually, the scale goes downwards. We're going to see examples of this in the next unit. So here it's 30 and 1. So I read it this way, though. So it'll be 30.123. So 30.3. And it looks like I'm right at that spot. So 0.30 milliliters. This is from something called a burette. I'll be using them in the solutions unit. And how about this one? This one, we're just going to be assuming it's a regular graduated cylinder. So here, looks like I've got a 0.5. This would be 0.6. This is 40, so this must be 36. And we're right on there, 0.0 milliliters. So again, what we're doing, we're recording all the digits that I know, plus an extra one. All right, how about this? We got to figure out the number of significant digits and rewrite each in scientific notation. So let's check this out. The rules for significant digits are easy, so anything 1 to 9 is significant. Trailing zeros, these ones over here, are significant. And I got something called the sandwich rule. If you're in between 1 to 9s, you're significant as well. Okay? Okay, so let's use these rules to help us figure out how many significant digits we have. So we got 1, 2, 3. Oh, and here we got a sandwich rule one. So this would be 4 significant digits. Here I've got 1. Oh, this is a trailing 0. This at the front doesn't count, so this would just be 2. Here I've got the 4, the 1, These are just size indicators. So they're placeholders. I don't use them. So it'll just be the 2. So let's rewrite this in scientific notation. So here I'd have 1.013. And I have to move the decimal place over 2 times. So this would be times 10 to the 2. Here, I'm moving the decimal place over. You always have one digit in front of the decimal place for scientific notation. So 4.0 times 10, and I moved it the other way, so this would be times 10 to the negative 1. Again, 2 significant digits in here. And this one, at the end, would be 4.1 times 10 to the 3. So I move the decimal place from here 1, 2, 3 times. You can see here how I only have 2 significant digits. That's it. So these are fairly straightforward rules. Okay, so I have to round each of these to the right number of significant digits. So here I'm going to be 2. So I start at this end, 1, 2, and then these are going to be rounded. I have to decide, am I closer to 110,000 or 120,000? Obviously, we're going to be closer to 110,000, so all I write down is 1, 1. And then you got to fill in the rest of the spaces here with zeros. So don't forget that. I can't just write down 11. I have to show that it's 110,000. I want to include the units as well. Here, I got to round to 1 significant digit. I have to chop right here. I have to decide, am I closer to 0.4 or 0.5? But wait a second. Let's look at this for a second. So what I have here is I've got a measurement that's exactly halfway between 0.4 and 0.5. Which way do I round? Use the even number rule. So here I'll be rounding this to 0.4 grams. And here, 2 significant digits. I'll be rounded right there. So this is an easy one. 2.6 times 10 to the 4th meters. Okay? Okay, now how about calculating and including significant digits with calculations? So let's look what we have here. So here I've got a graduated cylinder. It looks like I've got exactly 7.00 milliliters of liquid here. And here I've got about, let's see, 45 milliliters. So let's say I added 7 milliliters to this. So it would have the following. Milliliters, and remember it's 7.00 milliliters. What would we have? We'd have 52.00 milliliters. You got to remember, I have a lot of error here. This measurement's not very good. I'm within maybe about 5 milliliters or so. So I can't really record the total sum here as 52. Best I can do is 52 without any decimal places. So 52 milliliters. And this is the first rule for adding and subtracting significant digits. When you're adding or subtracting, you go to the least number of decimal places. You're limited by this measurement over here. Similarly, let's say I'm measuring the size of an object, and one person, their measuring device is limited. They can just say the length on this side is 4 meters, this side is 7.27 meters. And let's say I want to do the area. So we'd multiply the two numbers together. So I end up with 4 times 7.27, and up with this, 29.08 meters squared, right? Here's the problem. You're limited. You're limited by this first measurement. Remember, this first measurement is quite poor. It could be plus or minus a meter easily. We don't know how good that measurement is. So I can't write down 28.08. The best I can do is maybe like to one decimal, or one significant digit. That's what I'm limited to here. Even though this is 3, I'm limited by this one measurement here. So I have to write this as one significant digit. So this would be 30 meters squared. That's the best we can do because that's an approximation. Remember, there's a lot of wiggle room here. This whole area here is uncertain. So again, when you're multiplying or dividing, it's the least number of significant digits. If you're adding or subtracting, least number of decimal places. So something to keep in mind. All right, so let's do some math over here. So here we're adding. Because we're adding, we're using the decimal place rule. So here you're going to get a value of something 86 point something. Best I can do is 86.7. And then I include the units, milliliters. Why 0.7? Least number of decimal places is here. So not significant digits, but decimal places. Okay, let's look at this example. Now this one, we're multiplying and we're also dividing. Remember, this means division here. So what's going to happen is we're going to go around the final answer to the least number of significant digits. So you do all this work, you end up with 67.2, and the units here are going to be grams. It's important to have units. Now, least number of significant digits, you got 1, 2, 1, 2, 1, 2, 3. So 2 is the least number. So this has to be rounded to 2 significant digits. Here's the correct way of recording that value. Here you got to be careful. You're dividing. Be careful with scientific notation. So I get this value on my calculator, 3.695652, something like that, times 10 to the negative 3, it looks like. Okay, and the unit's going to be grams per milliliter. So let's look at the significant digits. So it looks like I've got 2 here, 2 here. Remember, the 0 is not significant. So I have to round this to 2 significant digits. So I have to decide, is this closer to 3.6 or 3.7? Here, we're closer to 3.7 times 10 to the negative 3 grams per milliliters. So make sure you go through the quiz, go through like anything you had difficulties with. This is a very important concept. You're going to be doing significant digits for the rest of the year. You're using it in physics this year and next year as well. All right, so take care.